Alright, so welcome to my presentation about AWS Reference Architecture, where we are going to discuss a couple of things regarding building this architecture on AWS and migrating to a data platform, but also discussing the total cost of ownership and return on the investment. So I don't know about you, but you definitely saw some of these graphs where there's like huge promises of a lot of percentages of return on investment. The capital is going to be put back into the business in half a year. There's much less downtime. The engineers are happier, and there's more efficient IT staff operations and applications delivered, etc., etc. So a lot of promises that are supposed to be fulfilled if you migrate to the AWS. And now the question is, how would you even proceed with something like this on one project, and what are the pitfalls and considerations you need to actually take care of while you're doing so? And that's exactly what we are going to tackle today. And a couple of things in regards to this, and major bullet points are how to design this AWS architecture, so meaning the high-level overview, what services are going to be included, how you're going to tackle the problem of existing on-premise servers and their migration to this new data platform on the AWS. And as I said, what are the positives and negatives to consider, what are the potential assumptions that need to be made and adjusted as we are going forward. Then the other point is, of course, you have to justify this migration with some numbers, quantify it, meaning calculating the total cost of ownership and then return on the investment. So there needs to be a comparison of what's the positive, what's the negative while doing this migration. And then finally, a general guideline for contract pricing. How do we even approach this? Meaning, how can one quantify the price of doing such migration, not only in the engineers' hours, but also on cost of having this infrastructure on the AWS. So what does it cost to spin up these services on AWS and upkeep them, etc., etc. So all the different costs that come with using the AWS infrastructure, but also migrating it and the engineers' effort. And from this point on, we can jump straight into the problem. And the problem at hand is a fictional company. It's a logistics company. That basically transports stuff all over Europe. So it has operations over 20 countries and delivers million full truckloads every year, with over 8,000 trucks fleet. And all of these informations should actually help us to understand that this is a big operation, and potentially they have a lot of on-premise infrastructure that needs to be migrated. In other words, there's a diverse set of data sources that we need to think about and take care of. And what they need to do now is create this data platform to compete and prevail in competitive market. And how would actually AWS infrastructure help them in this regard? We're going to find out in a short. But this is the problem that we have. This is the company. This is what they want to achieve, and obviously they don't even know the details. So for some of the things, we are going to have to make the assumptions and or ask directly with them to confirm whether the inflow of the data is correct, whether the requirement that they have high availability is absolutely necessary, etc., etc. So at every step of the process, it's kind of a feedback loop where we are asking them for information, but they are also making some assumptions based on our previous experiences that we can obviously then justify. Then next key point, what they do know and what they absolutely have to fulfill. And again, it's just a fictional scenario. We can add more requirements to this, and then architect based on these requirements, is they definitely need a consolidated data platform in the cloud. Meaning, as I said, they are a huge logistics company and they have a lot of data sources. So they want all of these data sources to be at one place in a data lake on AWS. we are going to see in a second, we are talking about non-IoT and IoT data, SQL databases, etc., etc. So a lot of data that resides actually on premise, and now they want to have it in one place unified, and based upon this, different solutions are going to be built. Next requirement is the business intelligence and ETL capabilities. So they need to actually perform analysis and extract some information from this data, and at the end of the day this should drive the bottom line. So it definitely needs to be useful, and transformation, loading, and all the process about handling the data should be automated. So they need to basically import the data into the AWS, and then with smart handling and transformation of the data, extract some business insights. Third point is the machine learning to optimize processes. This one is again a vague one because they don't know a lot about machine learning. They just know they have some data and they want to find smart solutions to automate their processes. Again, here we are supposed to aid them in giving them good recommendations about how can this be achieved on AWS efficiently. And we are going to talk about also about this architecture, meaning how can one design not only the data platform but also machine learning platform to automatically generate machine learning models and generate insights and automate stuff that needs to be automated. Fourth point is the high availability of the services, so they definitely cannot afford downtime. It's a huge no-no for them, and what we have to make sure with this requirement is that every service that we are constructing is actually experiences as little downtime as possible. So whenever some disruption happens in a certain region, we need to make sure that the services are still full up and operating. So there definitely cannot be outages, which cannot be guaranteed for the on-premise infrastructure, because obviously you are blocked by this single region where your on-premise servers are to be found. And finally, and most importantly, like, we have to be careful about cost effectiveness. They are definitely conscious about how much money they have to spend, and they need to know these numbers up front. So they need to quantify it and keep it low. And based on all these constraints, we are to build an architecture for the data platform and for the machine learning part, and obviously under certain assumptions, because their knowledge is rather limited. And if we jump straight into the data platform solution for this logistics company, this might look actually a little bit too big or too complex, but if we follow the dots and follow the individual comments, this should be actually pretty easy. As I said, this is just a data platform solution, so consolidation of the data, some machine learning, business intelligence and ETL capabilities. And then in the next graph, we are going to discuss this part furthermore. So the SageMaker is the suite of services that's responsible for machine learning, and we are going to see how can we orchestrate and design an architecture that deals with only this. But we can start from the first one and from the corporate data center, where basically two distinct groups of data are residing. So we have SQL and SQL Server databases. So these are Dynamics is just a customer CRM software, and the data resides in SQL Server. So these are the structured data sets that also need to be migrated. And the second one is telemetry data, so IoT data. From these trucks, they are measuring a lot of sensors, tire pressure, fuel consumption, etc., etc. But not only that, also image and video captures. So there's a whole diverse set of data that can be analyzed and processed. And first thing first on agenda, when looking at this, we want to think about how can we ingest this data. So how will it even be transferred to our AWS cloud? If we start with the SQL, as I said, this should be done with a couple of services paired together. So you see here the data migration service and schema conversion tool flowing into the Aurora database. The reason for this choice, and that motivates one of the requirements, is the high availability. So if you talk about SQL-based databases, the Aurora is proprietary software from AWS, but it has the highest availability, but also superior performance in regards to other databases. But that's not the only thing. It's also more expensive, which is also one factor to consider. But focusing and optimizing for the high availability, the decision was made to transfer this to Aurora serverless database. So not anticipating or projecting what the size of the future SQL database will be, but it can actually dynamically adjust to it and increase or decrease the capacity to accommodate this fact. And the reason why we need the data migration service and schema conversion tool is that obviously we need to migrate it, so we need to connect over the internet and then send the data slowly over the internet to the AWS cloud. But schema conversion tool, we need to convert the SQL servers to the Aurora database, because the Aurora database does not recognize this schema. It's not compatible with SQL Server, so this is the fact that we need to incorporate here in order to make sure that the data that actually resides here will also reside here in our Aurora database. So this is one inflow, one pipeline coming to this step of Aurora database. And now if you take a step back and go to the telemetry data, here, as I said, it's an IoT. So we need to think about other ingestion services that need to be performed. The good thing about this and the requirement that they had, again, hypothetical assumption, it doesn't have to be correct, is that the telemetry data is collected in a device that has a native AWS SDK for IoT core. What this means and what this translates to is that we can directly transfer the data to the AWS core and communicate with it. So over the internet, we can just push out the data in a streaming fashion to the IoT core, which resides obviously in AWS cloud, and can ingest this data to the cloud. Now you're maybe wondering, okay, but what's this green circle here? And we see some service called AWS IoT Greengrass and the Lambda at Edge. That will be relevant later on for AWS SageMaker. So when we make predictions on edge, on device, we will utilize this service. But as I said, given the assumption that this device already has the native AWS SDK IoT core kit, we don't need to think about Greengrass and actually using this hardware on our tracking on our trucks. So good. So the first step that we had to finish here is the ingestion part. And now that the data is ingested, we are thinking exactly in here, this step here, what are we going to proceed and do next? And there are a couple of options that I opted out for, and these are again under certain assumptions, right? The assumptions are concerning the amount of inflow of the data. So what I assumed was a couple of terabytes per week of data that's going to inflow. This could be actually on the lower end for IoT data and may not meet the assumption. So depending on that, maybe we need to reorchestrate. But given that there are a couple of terabytes of data, I decided that there are two possible options that we can do here and that are interesting for the business case and for the requirements posed. First option is to directly actually transfer the data from the IoT core using the Firehose to the data lake. So the data lake is our main repository where all of the data will reside, also the raw data and the process data. This is where everything is to be found, and based on this huge data lake, we are going to build further services. That's the SageMaker, that's the Athena and QuickSight for the business intelligence. But the other path, as you noticed here, is using the Kinesis data streams and Kinesis data analytics to perform streaming analytics. So what does this mean? Instead of waiting for the data to go into the data lake and then perform something here, we can do it almost automatically. As the data is flowing in, we can parse it with the Kinesis data analytics and use the ETL capabilities built in data analytics to do two things. First things, obviously, the transforming the data, loading the data and transforming it, and then sending it forward to the processed bucket in the data lake. And the other option, and that's the fourth option, is we can directly, in a streaming fashion, perform, for example, anomaly detection. So maybe to motivate this example is, think about all the IoT data that we are gathering, and these IoT data is, for example, tire pressure, so tires, measuring the tire pressure in the trucks. And what we definitely want to know almost instantly, we cannot wait for the data to be processed inside of the data lake. We want to know almost instantly if the tire pressure falls underneath certain threshold, and this needs to be basically then forwarded to AWS Lambda and the simple notification service to notify the driver or notify the center where this data is consumed, and then that will be propagated to the driver. But basically motivating the business need to almost automatically respond to certain changes in the IoT data, and that's this pipeline right here. But if we go back and we talk about the data lake, as I said, it contains raw and processed data. On both of these, we can do some computation based and built on this. We can then use AWS Athena paired with QuickSight to parse this data. So with Athena, we can perform SQL queries to pre-select and pre-query the data that's then going to be pushed into the QuickSight, and in QuickSight we can generate our dashboards, business intelligence summaries, analytics, etc., etc. This is very interesting because the QuickSight is a software as a service solution from AWS, and it's basically a substitute for Tableau or other business intelligence solutions. But what's interesting is that we can also integrate AWS SageMaker in here. So as you see, when we forward our data to SageMaker and we do the machine learning magic that we are going to discuss in a bit, then we can also embed these machine learning models in the QuickSight and enhance the business intelligence side. So now that we touched upon the AWS SageMaker, as I said, the data flows into the SageMaker suite or the SageMaker pipeline that's going to be discussed in a minute, and then smartly it can do the predictions either on edge or it can perform them here on the cloud and optimize the process. What is finally important, and that was the requirement, and as you can read from the 8th point, is that we definitely want to monitor our application. So if we can maybe take a step back before I discuss this monitoring of application and the final step, we can summarize what happened here. So we talked about data ingestion right here. We talk about data storage. We talked about some analytics and some processing right here. Then we talked about ETL and processing and how this is going to be propagated. And then we talked about machine learning part. So different use cases that we are going to go into details in a bit. And then finally, in this upper corner, we have the data governance, so monitoring what happens not only with the underlying resources but also with our costs. And here you have the AWS Personal Health Dashboard, which is actually a free service that allows you to anticipate certain disruptors in the AWS services. So given that we have the requirement of high availability, this is definitely going to be useful for us, and we need to know if some of the services are going to be experiencing downtime, and this is something we need to incorporate in our decision making as a logistics company. And obviously then the AWS budgets and AWS Cost Explorer, these are both used to analyze the current and make the projections on the future cost consumption regarding the AWS architecture. So what we can do with AWS budgets, we can set a hard threshold where we just don't want to overspend on the S3 buckets, and as soon as it hits, we can either get a notification, or we can actually opt out also to trigger to stop these services. And Cost Explorer to have a granular look at the data on a monthly, daily, weekly basis, and then also make projections and extrapolate how is this going to behave in the future. So this concludes the broad overview of the data platform solution. As I said, the main point is that needs to be discussed is the assumptions and the requirements that this company poses at the beginning, right? So if we are talking about cost assumptions where they say we really don't care about any other capabilities, all we want to achieve is high availability. So in this case, you just make sure that you don't have any unwanted services like anomaly detection, etc., etc. You just make sure that data is transferred to the AWS and it's highly available and it's cost efficient, etc., etc. And other assumptions were the amount of data inflow and the amount of data that's going to be transferred to the databases, right? So maybe here in Aurora database, another of the limits that it has over a capability over 100 terabytes of data to host. And if you are talking about some smaller SQL databases, so for example RDS for SQL Server has up to 16 terabytes. So if our databases are super small, maybe we can opt out for some less costly option, but then we would lose the higher availability capabilities. So this is definitely also something we need to take care of. Then talking about data lakes, again an assumption, do they want a long-term storage? So maybe we can talk about also S3 Glacier and another bucket that saves the data that's not going to be accessed and that's not relevant anymore for us. Then do they even want the machine learning solutions? Are they R&D projects, or are these machine learning solutions actually going to automate the processes and then help the bottom line? So these are all the discussions that need to be taken actually with the team and see what do they need and what's the MVP that's going to satisfy their business needs, and then at the end of the day actually fulfill the picture from the first graph with all these promises, with the huge ROI returns, with the innovation, with engineers attrition, with a lot of benefits that you get. We need to plan this upfront and discuss it actively with the team at this company. But I guess what we can jump straight into is the AWS SageMaker. And the SageMaker, and as I said, it's the machine learning solution and the machine learning suite of solutions to do, let's say, all things machine learning on the AWS. And this will look like something like this. So what I wanted to do with this graph and with this solution is to showcase, even though SageMaker can be a drag and drop kind of solution in the sense that you take your data, you use some off-the-shelf possibilities that the SageMaker offers you, and you can already expect to get pretty solid results and pretty solid automation. It can also get highly complex. And I'm going to take one example that's pretty relevant for the logistics company. It's tackling the problem of vehicle route optimization. And vehicle route optimization is one of the standard problems in computer science is NP hard, meaning it's really hard to compute the most optimal solution in polynomial time. And what we actually want to achieve with this machine learning architecture is to try to build a reinforcement learning solution to approximate the most optimal route that needs to be took in order to optimize the process and deliver the goods in the most cost-effective way. And the way this is going to work is again as the same. We follow the arrows and we take the points, and we see we are again from our starting from our old data lake where we hold our consolidated data, and in a automated fashion. So we trigger the Lambda function. So as soon as certain amount of data is filled up in the S3 buckets, we will trigger the Lambda function, which again triggers the AWS step functions workflow. AWS step functions workflows allows us to orchestrate workflow. As we see here, we can take multiple services and orchestrate them. How should they actually behave in a sequence? And we see here that this sequence takes part first with the AWS Lambda functions, where we check the input files on certain formats. We propagate the parameters that need to be accessed on the further steps, all the configurations that need to be also propagated furthermore, etc. And then the important part, because this data could be also raw, here we have a AWS Glue ETL job, so extracting, transforming, loading the data, and really making sure that the data that actually goes into the further steps of the machine learning models is cleaned. Once we have that, then we can potentially, here I left it on purpose, use the AWS SageMaker ground truth to label the data. Obviously, for the reinforcement use case, we don't need this. Labels are not needed. What we do need is reward function to tell if something is good or bad, but this will not happen in the supervised way where we need explicit labels. But this is a standard use case if we are talking about supervised learning and automating certain processes with supervised learning. But for the sake of being, let's say that this is not necessary in our specific use case, then we have the data. We then here can spin up the SageMaker Studio notebooks. So meaning we can use these Jupyter notebooks to do the research and development part, to benchmark the algorithms, to try to develop a better solution that actually performs well for the use case. Also, as part of that, we can not only develop something on our own, but there's the SageMaker marketplace where we can buy off-the-shelf algorithms. And also, when we are done with model selection, we can use hyperparameter tuning to have a more superior algorithm, meaning more superior weights that are going to then perform better later on. And then when we are done with the machine learning part, meaning cross-validation, making sure that it works as it should, etc., then we can host the model. So directly with the SageMaker, we can expose this endpoint and say, okay, the predict or fit or whatever endpoint can be accessed with the predetermined access point and endpoint. And this is all we need to expose this. And if we go one step back to this diagram, so let's say we are done here, then we can use this output, for example, with the AWS Lambda on Edge to perform the computation directly there, and serve the model on the edge. And this is definitely a viable option, because if we again talk about analogies and examples, let's say that these cameras are taking pictures all the time. What they need is an object detection solution that basically when the night falls and the drivers are tired, that object detection can automatically detect some signs, stoplights, warnings, etc., so that they keep the truck drivers alert and basically vigilant to be able to continue to drive on these hard conditions late at night. So this is definitely a potential use case that could reduce accidents and then at the end help the trucking company and their transportation business. So great. So this was the machine learning platform solution that I explicitly wanted to separate from the previous one, because it showcases that this part can also get highly complex depending on the need and the use case that we want to automate. But now that we are done and we presented the solutions, possibly we are going to have to make some adjustments, meaning assumptions are going to be changed, requirements are going to be changed, some services are not going to be necessary. But right after this, we need to talk about total cost of ownership, because if we are making a management decision about viability of cloud platform or a machine learning platform and this migration, we need to back it up with some numbers. To calculate the ROI, we need to first calculate the total cost of ownership and the cost of current IT infrastructure costs. So these means what do you have on premise? So that means maintenance labor, facilities, maintenance, staffing, real estate for the servers, utilities, and any other IT related costs. So contractors, warranties, supplies, network bandwidth, storage, database capacity, etc., etc. So there's definitely a lot of cost that the company should already know by itself. So how much are they spending on the current IT infrastructure costs? And then indirect costs are basically costs that are a little bit harder to measure. For example, loss of productivity suffered by employees and customers from infrastructure downtime. For example, other infrastructure related costs like cooling costs, power costs, infrastructure improvement, etc. So definitely a lot of potential dimensions to measure here and say this is what it costs us to run this on premise. And then if we want to directly estimate this on cloud, and strictly speaking about paying it to AWS services and without the engineering effort of implementing this, I use the AWS pricing calculator. And what you can do there is you can, with your assumptions, meaning the capacity that you need, the compute time, the compute resources that you need, etc., etc., etc. With these assumptions, you can enter your services that we architect before. So every service that we had here and here can go into this pricing calculator that I mentioned. And in this pricing calculator, we can make these projections under certain assumptions, and we are going to come up with this number, with around $5,000 US dollars per month. This is on the lower end, meaning the amount, the configured amount for these services that I assumed was not that high. So this could definitely go up or change depending on the requirements. Maybe we are going to kick out some services and we are not going to need them. But this is the rough picture approximation straight at the beginning. The other point is the AWS Trusted Advisor that you get for the enterprise and business accounts, where they help you actually to make these projections and further optimize your costs as you are building them. And there are obviously plenty of other tools that I already mentioned. The budgets, where you can explicitly limit yourself to restrict your consumption and really stay on budget in regards to your AWS expenditures. There's a lot of free tier services that you can utilize, so you don't have to pay for everything. And not only that, if you're a startup, you can also get a 100K subsidized by the AWS, meaning they will give you 100,000 US dollars to actually build your infrastructure for free, and then after that you will have to start paying. There's a cost explorer that basically allows you to manage your costs and usage over daily or monthly granularity. So this is more to help you to visualize and understand and manage your costs, and it actually is used after they have been incurred. And finally, cost allocation tags. You can definitely, as you can imagine, there are multiple sub-accounts and multiple teams using your AWS account, so you can tag certain teams like development team or business intelligence team, and then you can see, okay, if these teams are really high on capacity, or they require a lot of compute power, and then you can restrict based on the team usage. This was the point 2, where we spoke exclusively about cloud infrastructure cost that you're going to pay. But point number 3 is the estimated cloud migration cost. And then Here, obviously, we are just at the beginning, and it's really hard to make any estimation, given that given the variability and non-uniqueness of every IT project. So obviously, here I said 4 to 6 months without complex machine learning, but this 4 to 6 months was used based on all the reference architectures that I dug up from official AWS website, and I tried to compare what it looked like for them. But as I said, they are not really in vacuum, meaning they are different from each other, and that they would have to be analyzed in detail later on. But this would be a ballpark figure of what we are talking about time-wise, and then monetary $750,000 US dollar across this month, and this is easier to calculate if we have constructed our timeline, because then based on number of engineers and company hourly rate and release planning, there's a simple formula to input this, and then you get the monetary expense to construct something like this. Fourth point that I added that also needs to be thought about, because after the migration is done, obviously this is not going to work without human supervision. So continued integration and testing of the apps, training, labor, security, compliance, administration of the cloud solution. It needs to be forecasted in order to estimate the post-migration budget. Yeah. So this is definitely also a point that one needs to keep in mind, because that's some hidden cost that can be incurred later on. And now what I wanted to talk about briefly is exactly this paradox of estimation. So as I said at the beginning, if we at the inception, if we try to make promises there, the variability is high and it can be deadly. And obviously the clients are not going to appreciate if we try to do this in a fashion of uncertainty and not reliability. But later on, if we talk about construction and we narrow it down, then this is going to become much more safer and correct assessment. Then, as I pointed, the point number 3 was the difference between agile and traditional contract pricing and estimation. Here, what one needs to take care of is think, and this is tackling the previous point that I talked about the release planning. Like how are we actually making sure that the stakeholder, meaning it doesn't matter if it's your company, if it's some client that you're building for, if it's a friend, but anyone that assigned this task to you, or it's your project, how do we actually make sure that they are certain in delivery with fixed costs or with variable costs? So this is definitely makes or breaks the project, because if you cannot motivate the main decision makers, you're not going to be able to proceed with the project. And the difference between these agile and the standard contracts for software is exactly in the pricing. So the agile contracts focus on fixating the price first, but leaving the scope, as we saw, furthermore fixating the time and the cost first and leaving the scope variable, meaning the requirements and the features can change. But the traditional one is where the time and the cost varies and the scope is fixated, which has a lot of downfalls with it. And as I said, it just sounds better for the decision maker if you fix costs or not, and then make the other points variable. And agile contracts focuses on following points, meaning the requirements are going to vary, but we know exactly when and how much is going to cost to build this. The minimum viable product will be built with plus or minus some features, and these are the estimates that we want to deliver to the stakeholder, either to your team that you're managing, or to your boss, your client, or whatever. These are the figures that they need, and this is the estimation that they need in this process. there are a couple of points that can be followed and guidelines that need to be fulfilled as we are proceeding with this estimation and trying to come up with these figures of time and money that we talked about previously. What I'm trying to get at here is that these are rough guidelines that can be touched upon. They don't need to be followed rigorously, but still asking these questions in these different stages could definitely help. And the first aspect is we are trying to negotiate this project and implementation of this project in the first place is we need to see clearly what do we want to build. Like what is the need that we have in our business and what are the business objectives. So understanding these questions actually allows us to set the scale of the project. Another set of questions that we also need to answer is, do we need a prototype to test an initial idea or the concept or the technology? Or have we identified a clear proposition that has been tested with your market and you are ready to build your first minimum viable product? So think about the startup ecosystem. So if in this case, what are we trying to do? Are we trying to build something from new? Or if we are not a startup and we don't need to be building something from scratch, is this an existing business that needs to scale and compete in the present market? That's why I took the logistics company. So it's already present old business and hence calling it a client, but they need to basically move in order to stay competitive and relevant with their business. The next point was high level epic features. Here we want to define the features that product has to have to fulfill the needs posed by the stakeholders. So this is like a structured shopping list that describes the bare bones of the product. And often these are referred as user stories or epics. And then building upon this is the Moscow analysis, meaning it's a technique only that helps identify what is really necessary to make the product viable and what is a nice to have. So this is just an acronym to identify a must that will satisfy and the users to engage and adopt the product. Those features that we identify as should will surprise and delight your customer but could be built later. The could items add no significant business value, may not increase the return and are the lowest of the priorities. And finally, the W, the won't features could well be important one day far in the future, but are out of the scope for the current project. And identifying these is very important because knowing not to what to focus on is highly helpful in building the MVP. The next step in the pipeline, let's say, of creating and pricing the contract is the proposal. So what are the things that we want to ask in this step? Basically, what will it take to create the product we want, and when can we launch it? Finally, does this actually align with our business strategy and finances? As I said, very importantly, we have to keep the features and scope vague, since to do the otherwise, we would suggest that we know exactly what is required. Remember, guys, in the Agile contract pricing, we are not fixating the scope, meaning the requirements, but the time and the money, because this allows us actually more freedom. And that's the main focus that we are trying to do in this proposal stage. We are obviously taking previous reference architectures and inspecting costs and duration. That's exactly what I did here. I tried to go back to some older examples of similar companies that built a similar AWS solution, and then I tried to build upon that with my assumptions. How is this going to look like and how much is going to cost? And if accepted in this stage, we move to the third stage, and that's the release planning. And this is the fact that I mentioned before in the engineering cost assumptions or calculations previous slides back. And this one, in one sentence summary, is to deliver a range of features in a given time frame. So we derive these list from a features, the size of the project, and how quickly our team can develop quality software that meets customers' expectations, and techniques for managing the risk of uncertainty. So, long story short is, in the release planning, there are a couple of bullet points that I listed here, 4 of them to be exact, that we need to take care of in order to plan this release and really see the path to building this, at the end, software project. The product backlog is simply an ordered list of epics or user stories that represent features required for the product. So this list, as I said earlier, starts as the epics that we discussed in step number 2. But between the assigned project team, the project manager, and the customers, we now break these down into more meaningful items. So we go into more detail, and each of these items represents a portion of business value to the customer. So we don't go into more detail at this stage, but we don't need to know the acceptance criteria. Yeah, we don't need to know if a button is blue or green. We just need to know that there is a button that allows some task to be performed, right? So from the epics to the stories, but not into super detailed stuff. Point number 2, estimation. So we have a list of features that we described as user stories, but now what we want to achieve, that we want to estimate the discrete items of features using different techniques. Here I named planning poker as one of the technique, but what this technique basically ensures quick, reliable results based on expert opinion and analogous sizing. So what I mean by this is that planning poker just assigns an agreed number to each item, representing its size and complexity. So like thinking about meritocracy, there's a lot of team members that's going to assign these numbers, so senior engineers, product managers, designers, etc., and depending on their experience and knowledge, they're going to have different weights. But this is not the only agile estimation technique available. There are countless others like ideal days, etc. But we are trying to achieve is basically size our tickets. Then point number 3, prioritization. Now in this step we already have a backlog and the size for the project, and we are in a position to set the priorities with the customer. So this is really about identifying what's the most valuable to the customer in order to achieve the desired results. The items at the top of the list are going to be considered more important, the second item is less important, etc. And finally, to conclude this, the approach to prioritization is an important milestone in planning this sort of migration or software project, because we know what is important to the customer and in which order to complete the work. If we take care of this, the project can actually take steps in a further direction that the stakeholder or the manager or the boss or the customer is going to be satisfied, and they're going to confirm and allow further steps in this direction. And as I said, the fourth is the release planning as the fourth point, where we actually need to define what done means. So now we are going into more details and assigning these numbers to the story points. So this means given a set I'm sorry. So defining what done means given a set of criteria that the customer will accept as complete. So what this works for us is it basically tells us what needs to be done for this feature or requirement to be selected as completed. And what we need to do when specifying this, we need to calculate the anticipated velocity. So it's basically taking the total number of story points from our sizing of our backlog and then dividing that by our team's anticipated velocity. Velocity is just it's how many story points we anticipate to finish in one iteration cycle. So here we say it's a 20 point per sprint. If a sprint is a week, we expect to finish at least 20 points as a team per week that we assign to these tickets. Now these numbers obviously are a bit maybe vague for non-technical or non-engineering people, but what they need to showcase here is just confidence in giving an exact estimation figure to the number of TOC that we mentioned earlier. So if we can estimate the velocity, meaning if we can have total story points for our migration project, this is going to flow into the TOC calculation that I mentioned earlier. So that's the release planning part that we need to calculate this number. And now that we have this number, then we can multiply it by company engineering hour, and then we can multiply it by the total time that the project is going to be invested in. Then at the end, we have our projected cost for the project. This slide is important reminder about the 5 design principles of or 5 pillars of well-architected framework. So just like in software development, where we have solid principles and other design patterns, also for the AWS, we are basically optimizing or orienting ourselves towards these 5 pillars, which with all of them represent different principles that need to be included. So if we take, for example, security, we are talking about implement a strong identity foundation, applying security at all layers, automate security best practices, protect data in transit and at rest, keep people away from the data, only the most important figures, and prepare for security events, etc., etc. So it's basically a guidelines what we need to optimize on. And the reason why I included this slide is, in our case, we were optimizing for reliability and cost optimization. The end result or consequence of this is that when optimizing for certain pillars, others are going to suffer. So some of the principles or requirements from other pillars are not going to be able to be fulfilled because other pillars were maxing out or were being optimized upon. So this is always something to keep in mind, because if we have a requirement or we are building our own startup and we realize we need to come to the market fast, we need to build and push out this MVP as soon as, then obviously in this case, some of the security or operational excellence is going to suffer because we are not taking care of all of these steps and all of these pillars. So this is definitely a consideration to be made. And finally, as promised, we were going to talk about ROI. So what's at the end of the day return of an investment? So let's say, again, you're a startup, you just built your product on premise, and now you are thinking about moving to the cloud to enable innovation, agility, etc. So how can you even measure this? Now, as we see from this simple formula, the ROI entails financial cost, but what we don't see is the intangible value. And it would be great if we could have a exact figure here to say us what's our ROI, but this is hard to measure. It's not that hard if our goal is clear, but it is if we include the intangible benefits. So what do I mean by that? The goal being clear means that if we opt only for a small set of desired requirements or benefits, then calculating this would be relatively straightforward. Take, for example, the high availability. So if we only care about high availability of our services, we can calculate current costs of our on-premise cloud and then costs of moving to AWS, and then basically subtract the gain from investment, cost of investment. So it could definitely be comparable, and certain statements could be made about return on the investment, because if you have 5 data centers that allow high availability, and then moving this to the AWS would be much cheaper, and it would be on demand, etc., then you would see that the ROI is huge. And the most importantly, it's easier to compare and make some statements about it. But if you talk about intangible, then it gets a little bit trickier. I want to preface this and say a very important note is that costs don't factor in value, but at the same times, these exact numbers, meaning the exact number of ROI, lends a sense of accountability and due diligence to the migration as a whole, right? So it makes you accountable to the process. But as I said, it's a much complex equation if we talk about intangible values, and right there we talk about faster innovation. So what does faster innovation means? We can have better algorithms, better software solutions from the cloud providers like QuickSight. It's easier to configure ETL jobs. We are not reinventing the wheel from scratch, right? We can optimize our operations much better. We can perform different machine learning use cases, as I said, demand forecasting, reinforcement learning, etc., easier with some of the off-the-shelf solutions from the AWS. If you talk about back office innovation, so we can basically anticipate customer needs through machine learning and CRMI software that I mentioned earlier, and that was instrumental for this company. And then chatbots that can do the customer service, report generations, invoice and bill sheet processing, etc. So there's definitely a lot of innovation and optimization that can be done much easier on the cloud than engineering attrition. So engineers always want to work with the best and newest technology, and they are not that motivated to work when there's a lot of upkeep and infrastructure problems and downtime. So this is definitely going to help in keeping them happy and satisfied and working on the newest technology. Increasing competitiveness. Obviously, you are being able to produce more quality and faster services and products using the AWS. So this is going to reflect on your competitiveness in the market. You're going to be able to reduce costs. Why? Because you are not buying based on demand. You are only paying for what you consume, meaning you're paying dynamically based on your needs currently. So in the standard on-premise environment, you're going to buy huge lumps in a batch, and then there's going to be times where there's a lot of unused resources. In cloud, this is not going to happen. It's all on demand, and it's basically adjusted for your needs. And there's a lot of other benefits that are also available, but this was a summary of intangibles that are definitely valuable to look at and need to be taken into consideration when looking at the bigger picture of ROI, of cloud migration, and building these data platforms and machine learning solutions.